This is SpaceTime, Series 26, Episode 144, for broadcast on the 1st of December 2023. Coming up on SpaceTime, explaining why galaxies like to hang out with their own kind. NASA's Cold Atom Lab sets the stage for quantum chemistry in space. And it's third time lucky for North Korea as they finally successfully launch their new spy satellite. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study may have solved one of the most perplexing mysteries in astronomy: why galaxies in our local neighbourhood tend to hang out with their own kind. Our own galaxy, the Milky Way, is part of a much larger formation known as the local supercluster structure, which contains several massive galaxy clusters and thousands of individual galaxies. Due to its pancake-like shape, which measures roughly 1 billion light-years across, it's also referred to as the supergalactic plane. Most galaxies in the universe fall into one of two basic broad categories. They're either round and elliptical, made up mostly of older stars and typically contain an extremely large supermassive black hole at their centre, or they're swirling spiral galaxies like our own Milky Way, with majestic star-forming arms and a generally disk-like structure. Both types of galaxies are found in the local supercluster. But while the supergalactic plane is teeming with bright elliptical galaxies, bright disk galaxies, like the Milky Way, are conspicuously absent. This unusual segregation of galaxies in the local universe, which has been known about since the 1960s, was listed as one of astronomy's great cosmic anomalies by cosmologist and 2019 Nobel laureate Jim Peebles. Now, astrophysicists including Till Swallow and Peter Johansson from the University of Helsinki appear to have found an explanation. Their research, reported in the journal Nature Astronomy, show how different distributions of elliptical and disk galaxies tend to arise naturally due to the different environments found inside and outside the supergalactic plane. Swallow says that in the dense galaxy clusters found on the supergalactic plane, galaxies experience frequent interaction and mergers with other galaxies. That leads to the formation of more and more elliptical galaxies and the growth of very big supermassive black holes. By contrast, further away from the galactic plane, galaxies can evolve in relative isolation, which helps them preserve their unique spiral structures. The team reached their conclusions after running detailed computer simulations, which followed the evolution of the universe from 13.8 billion years ago right through until today on supercomputers in England and Finland. While most similar simulations look at random patches of the universe which can't really be directly compared to observations, this more detailed simulation aims to precisely reproduce the observed structures of the universe, including the local supercluster. And according to the authors, the final result of their work is remarkably consistent with observations of the real universe. This is SpaceTime. Still to come, NASA's Cold Atom Lab sets the stage for quantum chemistry in space, and it's third time lucky for North Korea as they finally get their new spy satellite into orbit. All that and more still to come on SpaceTime.
This episode is brought to you by Dragon Ball Legends, the ultimate Dragon Ball experience on your mobile device. Dragon Ball Legends features action-packed anime action RPG gameplay with Goku, Vegeta, Trunks, and all your favorite Dragon Ball characters. Summon your favorite characters from popular Dragon Ball anime series, such as Dragon Ball Z and Dragon Ball GT to Dragon Ball Super. Fight in real time against friendly or rival Dragon Ball players from across the globe in live PvP battles. Enter ratings matches with your favorite Dragon Ball characters and earn rating points and rewards. Unite with friends to defeat powerful foes in co-op. Dragon Ball Legends features the best anime fighting scenes on your mobile device. And now, Legends Festival is on, so you can get up to 300 free summon tickets. Are you ready? Download Dragon Ball Legends today. Available for free on both iOS and Android devices.
You're listening to SpaceTime with Stuart Gary.
For the first time ever in space, scientists have produced a quantum gas containing two types of atoms. The research was undertaken by NASA's Cold Atom Laboratory aboard the International Space Station. The experiment, reported in the journal Nature, marks another step towards bringing quantum technologies currently available only on Earth up into space. Quantum tools are already used in everything from cell phones and GPS to medical devices and secure encryption technology. In the future, they could also be used to enhance the study of planets, including our own, and to help solve other mysteries of the universe, while deepening our understanding of the fundamental laws of nature. The new work was performed remotely by scientists on Earth using the enhanced capabilities of the Cold Atom Lab, which can study not only quantum properties of individual atoms, but also quantum chemistry. This focuses on how different types of atoms interact and combine with each other in a quantum state. Researchers will be able to conduct a wider range of experiments with the Cold Atom Lab and learn more about the nuances of performing them in microgravity. The physical world around us depends on atoms and molecules staying bound together according to an established set of rules. But different rules can dominate or weaken depending on the environment the atoms and molecules are in, like microgravity. Scientists using the Cold Atom Lab are exploring scenarios where the quantum nature of atoms dominates their behaviour. For example, instead of acting like solid billiard balls, atoms and molecules can behave more like waves. In one scenario, the atoms in 2 or 3 atom molecules can remain bound together but grow increasingly far apart, almost as though the molecules were getting fluffy. To study these states, scientists first need to be able to slow the atoms down. They do this by cooling them to a fraction of a degree above absolute zero, the coldest temperature matter can reach, minus 273 degrees Celsius, far colder than anything found in nature. Scientists have created these fluffy molecules in cold atom experiments on the ground, but they're extremely fragile, and they either break apart very quickly or collapse back down to their normal molecular state. For this reason, enlarged molecules with 3 atoms have never been directly imaged. But in the microgravity conditions aboard the space station, these fragile molecules can exist for longer and potentially get larger. These types of molecules likely don't occur in nature, but it's possible they could be used to make sensitive detectors that can reveal subtle changes in the strength of a magnetic field or some other disturbances that cause them to break apart or collapse. Cold Atom Lab project scientist Jason Williams from NASA's Jet Propulsion Laboratory in Pasadena, California, says cold atom science is looking for and learning about new tools that nature provides. One use for quantum gas with 2 types of atoms would be to test something known as the equivalence principle, which holds that gravity affects all objects the same regardless of their mass. It's a principle that many physics teachers will demonstrate by putting a feather and a hammer in a sealed vacuum chamber and showing that in the absence of air friction, both will fall at the same rate. Now, if that sounds familiar, back in 1971, Apollo 15 astronaut David Scott did the same experiment on the surface of the moon without needing a vacuum chamber.
Well, in my left hand I have a feather, in my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the 2 of them here, and hopefully they'll hit the ground at the same time. How about that? Which proves that Mr. Galileo was correct in his findings.
Using an instrument called an atom interferometer, scientists have already run experiments on Earth to see if the equivalence principle holds true at atomic scales. But using a quantum gas with 2 types of atoms and an interferometer in the microgravity conditions of the space station, they could test the principle with far more precision than what's possible on Earth. And doing so, they may learn whether or not there's a point where gravity no longer treats all matter equally. Now, if that happens, it would change Albert Einstein's general theory of relativity, which has never failed, and that would have massive implications. The equivalence principle is part of general relativity, the very backbone of modern gravitational physics, which describes how large objects like planets and galaxies behave. Put simply, Albert Einstein's theory of general relativity describes the universe on a cosmic scale. But a major mystery in modern physics is why the laws of gravity don't seem to match up with the laws of quantum mechanics, which describe the universe on the subatomic scale. The laws of both have proven to be completely correct in their respective size realms. but physicists are still unable to unify them into a single description of the universe. Looking for features of gravity not explained by general relativity could be one way of searching for a means of unification. Scientists already have ideas that go far beyond testing fundamental physics of microgravity inside the cold atom lab. They've also proposed a space-based experiment that could use a two-atom interferometer and quantum gases to measure gravity with high precision in order to learn more about the nature of dark energy, that mysterious force behind the accelerating expansion of the universe. What they learn could lead to the development of precision sensors for a wide range of applications. The quality of those sensors will depend on how well scientists understand the behaviour of these atoms in microgravity, including how the atoms interact with each other. The introduction of tools to control the atoms, like magnetic fields, can make them repel each other, like oil and water, or stick together, like honey. Understanding these interactions is a key goal of the Atom Lab. This report from NASA TV.
We are dominated by the very small. We don't even think about it. We take our phone out of our pocket. We don't think of our phone as being that small, but there are billions of things, of transistors inside your phone. We're used to high-tech, always moving smaller, smaller, smaller. But we're running up against some limits, and those limits are that as things get smaller and smaller, the physics that controls how things act, the underlying science, instead of being the old school physics, which is called classical physics, which you can think of as like pool balls rattling around on a table and clacking into each other, as you get very, very small, instead of acting like these little balls, they act more and more like waves. And the underlying physics is not called classical physics, it's now called quantum physics. Where things start getting complicated and harder to understand is when you have collections of atoms or collections of electrons bouncing off each other, passing through each other on their way through our tiny little transistors to turn on and off the ones and zeros on our tiny computers. These problems are hugely more complex, and so oftentimes we have to do experiments to understand them. That's where the ultra-cold temperatures come in.
If you cool atoms down to some of the coldest temperatures you can imagine, colder than any other place in the natural universe, the atoms are moving very, very slowly. And if you're going to make some measurements about their properties, if they're moving slowly, you can make that measurement a lot more precisely. If all the atoms in this room right now are moving around at 770 miles per hour, the speeds that the atoms are moving once they're cooled is slower than 1,000th of a mile per hour. A cold atom is a controllable atom. You let them out of the trap and they just float.
We're cooling the atoms down to a fraction of a billionth of a degree above absolute zero. At a temperature so low, we can easily see these atoms for tens of seconds and study and see their dynamics and how they interact with each other.
To do that, we have to be in space. We have to take quantum matter and quantum technologies into space. And we have to work hard to learn how to use quantum technologies in space. And the Cold Atom Laboratory is the first dedicated laboratory that will allow us to do this sort of work.
These types of experiments are the most challenging tabletop experiments that take place on Earth. So to take this up to the space station is a whole new level where we'll have to operate remotely and have a robust working instrument. The Cold Atom Lab will also allow us to free those type of experiments from the constraints of gravity that plague researchers on the ground. Gravity always drags atoms to the bottom of the traps that we use, and in the Cold Atom Lab, we don't have that problem.
When we discovered Bose-Einstein condensation in 1995, the experiment was complicated and difficult. I would have never imagined that it is possible to do such experiments now on a space station. With Bose-Einstein condensates, we reach nano-Kelvin temperatures, so all the atoms have an extremely low energy. So therefore, going to microgravity eliminates a number of limitations for the experiments.
Ultra-cold acts like a magnifying glass. It expands the effects of quantum mechanics. That's really the power of these very low temperatures of the Cold Atom Laboratory, as we can learn about these things as we get colder and colder yet.
And in that report from NASA TV, we heard from Cold Atom Lab Principal Investigator Eric Cornell, Co-Principal Investigator Nicholas Bigelow, Science Testbed Lead Ethan Elliott, Principal Investigator Jason Williams, Cal Science Review Board member Ron Walsworth, Cal Science Review Board Chair Brian DeMarco, and Cal Co-Principal Investigator Wolfgang Ketterle. This is Space Time. Still to come, North Korea launches a new spy satellite. And later in the science report, new studies show that dust storms are dramatically increasing in frequency across Australia. All that and more still to come on Space Time. North Korea claims it successfully launched a new spy satellite. The flight's been strongly criticised by the United States and its allies as a brazen violation of United Nations sanctions. It was a case of third time lucky, as two previous launch attempts by Pyongyang in May and August both ended in failure. The 300-kilogram Malagyong-1 military reconnaissance and surveillance satellite will allow the North to improve its intelligence-gathering capabilities over South Korea, providing crucial data in any military conflict. The spacecraft was launched aboard Pyongyang's new three-stage Kalinia-1 rocket, which appears to have abandoned the previous Scud missile-based Unha rocket design in favour of newer Hwasong 15 and 17 intercontinental ballistic missiles with more advanced rocket engines based on Soviet ID-250 motors acquired from Moscow in exchange for munitions to help Russia in its ongoing invasion of Ukraine. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Scientists have found that sand and dust storms are dramatically increasing in frequency across Australia. A report to the United Nations Convention to Combat Desertification found a single sand and dust storm event in Australia in 2009 resulted in damage estimated up to $243 million. Researchers have found that at least a quarter of these events are caused by human activities such as land clearing. The authors say while sand and dust storms can fertilise both land and marine ecosystems, they also present a range of hazards to human health, livelihoods and the environment. Scientists claim current research into the impact of screen time on kids and teens are showing mixed results. A report in the journal Nature Human Behaviour looked at 32 existing metadata analyses on screens in young people and conducted their own meta-analysis, combining results on how different types of screen use impact health and education. They say there was evidence for both positive and negative impacts of screen use, often dependent on the type of screen use involved. For example, while literacy was slightly reduced in children who use screens more, literacy was actually improved in kids who watch TV with their parents. The researchers say the findings are currently limited by a lack of high-quality metadata analysis in this area, and more research needs to be done to get a clearer picture on how different contexts influence the impact of screens. 27 avian footprints, discovered at the Wonthaggi Formation in Victoria, are revealing the amazing diversity of Australia's early avian population. Bird fossils are hard to come by in the Southern Hemisphere, and the 120 to 129 million-year-old footprints are some of the oldest known evidence for birds living in Australia during the Cretaceous period. A report in the journal PLOS ONE claims the footprints show birds living in the region at the time varied in size and shape, and some were among the largest known Cretaceous birds anywhere on the planet. In a session of the United States House Oversight Committee investigation of claims regarding UFOs, witnesses have testified that the government's been aware of non-human activity since the 1930s. Academics testified that it was possible that aliens could have visited the Earth, but it was difficult to imagine them doing so, and that witnesses had provided insufficient data to form an opinion on the matter. Others pointed out that there's simply no evidence, only hearsay, and certainly no scientific input. Some committee members pointed out how astonishing it was that these hearings have gone this far. Journalists watching the hearings have also expressed a range of views. One reporter who studies UFOs described it as part of a legitimately historical shift in serious people having serious conversations about the subject. Others less enthralled in the topic say it's very clear that some people have been successfully getting the ear of certain politicians. As far as the politicians are concerned, the prevailing view seems to support the idea of multi-billion-dollar military black ops programs being behind the whole thing. Either that, or high-tech military aircraft flying with really badly calibrated equipment, and that would reflect badly on the training of ground crews. Republican Representative Mike Turner has drawn the consternation of some of his fellow party members over his apparent reluctance to support legislation aimed at providing greater transparency on unidentified flying objects. Meanwhile, fellow Republican Representative Tim Burchett from Tennessee talked about the obstruction of a UFO-related amendment he had offered regarding the Federal Aviation Administration. Burchett suggested that defence contractors are using campaign donations to influence members of Congress against UFO-related transparency efforts. He told assembled journalists he thought it would be wise for reporters to begin looking at the financial disclosures of some of the corporations who have been stonewalling the hearings. Tim Mendham from Australian Skeptics says it all shows that conspiracy theories abound just as strongly in politics as they do among UFO enthusiasts.
Yeah, there's been a lot recently, obviously. UFO has been in the headlines, initially with the Pentagon and NASA public statements saying they have investigated these, quote, phenomena, close quote.
And will continue yeah.
And fair enough, they should do it. Yeah, nothing wrong with that. And what they found is that a percentage are unknown. Because people, when they hear unknown, they think, flying saucers. No, it's unknown. Unknown is in the term UFO, right? It's unknown. It's also in the term UAP, which is the more modern version, unidentified anomalous phenomena. So, but it's still unknown. So unknown is unknown means you haven't found out. So you can't say. But that hasn't stopped a lot of other people from saying they do know. And recently, with this, there's been a fellow named David Grush, who's ex-Pentagon investigating UFOs, who's now come out and spoken openly.
Yeah, he doesn't say he's seen them. He says he's had reports of them given to him.
Yes, totally third hand.
Exactly.
And the reports haven't. The people who report to him or have told him haven't supplied any evidence. Of course, they can't, as we know. And then he can't supply any evidence. All he's saying is that I'm told that this exists. And you think, well, that's not very good. It wouldn't stand up in court. But apparently it stands up in American politics. And there's three groups here involved.
If you lie in a committee hearing, that is perjury. That does give you jail.
Yeah, well, he's not lying. He's just saying what I've been told.
Exactly.
Now, whether he has been told, that could be lying. Or whether the people telling him are lying, that's a different issue. But if all he says, I've been told, yeah, I've been told too, but it doesn't mean it's true. So therefore, there's enough politicians out there who do believe, who are making all sorts of claims. For instance, there could be a conspiracy, they're covering it up, blah, blah, blah. I think there was one person who said there was a politician, someone like there's a representative from Tennessee who said, we're going to uncover the cover-up, which obviously means that there is a cover-up. And there's a whole range of sort of politicians, some who are firm believers and some who believe it's very dodgy, who are sceptical of the whole thing. There are others who are claiming that, of course, the military-industrial complex is covering it up and they're paying these politicians as part of a conspiracy. Then you get the third group. So you got believers, you got politicians, then you get scientists who are commenting on it, and they come down to the obvious skeptical conclusion, show me the evidence. And there's an age-old line that I use in trying to explain what skepticism is, and if you say you can fly, I say, show me. I don't say you can't fly, just show me the evidence. Now, it's up to you to show me the evidence because you're the one with the claim. And that's the trouble with all these UFO proponents, whether it's believers or politicians or whatever, there ain't no evidence. Well, what evidence there is very poor and increasingly suspect as people carry cameras and movie cameras around with them in their pockets these days, which are very high quality, and they can pull out very quickly and take a rapid number of photographs or whatever. There's still no evidence. And that's the dilemma that faces scientists. And these reports that have been coming out talks about scientists saying there's just not the evidence. It'd be great if it was true, but there's just not the evidence. So I'm not going to jump down that particular rabbit hole. But there always are a number of scientists who come out and they firmly believe it's true. But that doesn't stop a lot of others. So, yeah, there are scientists who are coming out against it, and there are politicians who still say the government's doing a cover-up.
I think the general agreement now is that it's probably not a foreign military or anything like that. It's probably just an anomalous event, either in the camera mechanism or something meteorological that hasn't been explained, or something quite normal like a weather balloon. So it's going to wind up being something like that. It's not going to wind up being something from another planet controlled by little green men, or should I say grey men, isn't it?
Yeah, grey men these days.
The lizard
serious
people.
proponents of UFOs will admit that most sightings are something quite explicable. But they'll hang on to that little small percentage of things that haven't been explained and saying because they haven't been explained, that gives an opening to a belief in UFOs. And as much as it'd be fun to have aliens here, and it would, as one scientist said, it would take the pressure off us knowing that we're not alone.
Not sure which is more frightening, knowing we're alone in the universe or knowing we're not.
Yes.
And in fact, if we look at what's happened here on Earth, whenever an advanced civilization has made contact with a more primitive civilization, that hasn't turned out well for the more primitive civilization.
It hasn't been a great history of success, yes, for the indigenous civilization, yes. So especially, as was it Arthur C. Clarke said, to any advanced technology looks like magic to someone who doesn't know it.
That's Tim Mendham from Australian Skeptics.
And I, for one, welcome our new insect overlords. Like to remind them that as a trusted TV personality, I can be helpful in rounding up others to toil in their underground sugar caves.
That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.